Okay, these are the chapter 6.6 notes. This is page 2. I realized the heading was wrong. I obviously cut and pasted and used the format, so hopefully nobody got confused by that. We are going to take a look at a couple of the situations that aren't super obvious to start, but once you see them, you know what to look for. Okay? So this first one, D, e to the x plus e to the negative x minus 6 equals 0 is actually quadratic, even if it doesn't look that way. So I'm going to start by rewriting this and remembering that e to the negative x means 1 over e to the x. That lets me know what I need to do next, because I can't solve for a variable in the denominator, much less in the exponent of the denominator. And then I'm going to rewrite this in descending order. And then this becomes a quadratic. So if it helps, so e to the x times e to the x is e to the 2x. This becomes u squared minus 6u plus 1. Okay. Now, I am writing this in blue because we have to be careful when we solve this that we don't think just because we got an answer, that's the answer to our original equation. I'm using the quadratic formula because this one cannot be factored. I got 6 plus or minus the square root. What is that? 36 minus 4, which is 32, all over 2. 6 plus or minus 32 is 16 times 2, so square root of 16 is 4 times the square root of 2 over 2. And just a reminder, because we had this issue, that 2 in the denominator applies to everything. So I got u equals 3 plus or minus 2 square roots of 2. Okay. Got to remember that we were not solving for u. We were solving for e to the x, or that exponent up there. Sorry. And so I got e to the x equals 3 plus 2 square roots of 2. And e to the x equals 3 minus 2 square roots of 2. And I'm pretty sure there's a mistake in the answer key here because I knocked off the 3 minus 2 square roots of 2, thinking that was negative, but it's not. Okay, so now we got to take the natural log of both sides. Natural log of e to the x is the natural log of 3 plus 2 square roots of 2. Make sure you get those parentheses in there so it's obvious what we mean here. X equals the natural log of 3 plus 2 square roots of 2, or x equals the natural log of 3 minus 2 square roots of 2. X is approximately equal, we'll go with this one first, negative 1.7627. Please let me know if I have screwed something up and you get something different. And this other one here, I get x equals 1.763. And actually, I meant to switch back when we change this to our exponential again. So hopefully that makes sense. All of this is in terms of the e to the x. Okay. Now for E, sometimes when we look at these, we want to make them more complicated than we are. This is a log base 3 of x equals -2. There's not anything that's going to be straightforward. But if I remember this, log base b of y equals x, that's the same as b to the x equals y. I can rewrite this as 3 to the -2 equals x. X is 1 over 3 to the 2, 3 squared, 1/9. Whole lot easier than it looked. So if we remember how, we rewrite this as the exponential, and we are way more comfortable with those. Right? F, we've got a common log, but I'm going to start by using the product property, and I am going to multiply the arguments on the left-hand side. Okay, now a quick reminder, common log means we're dealing with a log base 10, so I'm going to use what I did just a minute ago. I'm going to multiply this part out. I get x squared plus 3x equals 10 to the 1. Okay, sorry, 3x, not 3 to the x. So getting everything on the same side by subtracting 10. This one I can factor. Always much better to factor if you are comfortable with it. So I get x equals -5 and x equals 2. Now, here's what we have to check on. The -5 domain on log for any of the logarithmic functions is 0 to infinity. So that means this -5 doesn't work. X equals 2 is our only solution. Right? Same thing here on the next one. I got log base 3 of 2x minus 1 minus log base 3 of x minus 4. I'm going to rewrite those as the quotient. Only have that single log on the left-hand side, so I can rewrite this. I can multiply both sides by x minus 4, so I get that out of the denominator. I get 2x minus 1 is 9 times x minus 9 times 4. Subtract 2x from both sides. Add 36. I get x equals +5. I double check in there. 2x minus 1. 10 minus 1 is 9. I can take log base 3 of 9. That's fine. And then x minus 4, 5 minus 4 is 1. That's also positive. That works. Down to our very last one. I got the natural log. And again, a lot of times these look gross. They're really not that bad. So I'm going to use the quotient product, the quotient property. And then realizing that if I'm taking the natural log on the left-hand side, and that's got to equal the natural log on the right-hand side, then that argument on the left-hand side just has to equal the argument on the right-hand side. I'm going to multiply both sides by that x plus 5 to get it out of the denominator. I'm going to move everything to the same side. And then I'm going to go ahead and factor. Oh my goodness. I get x equals -3 and x equals 2. Again, that -3 is not going to work. And I mean, all I got to do is check this one. I cannot take the natural log of -3. So my solution here is just x equals 2.